The input on TriceraChorus can be configured for mono or stereo operation using the switch below the input connector. Mono is great when the input signal is one channel, like a guitar, a monophonic synth, or signal coming from a preceding mono pedal. For this connection, only a regular instrument cable is necessary. When connecting a stereo signal to TriceraChorus, make sure the switch is set to stereo and use an insert cable to connect the stereo outputs of an instrument or pedal to TriceraChorus's input. For example, to connect an Eventide H9 Max in stereo, connect the tip plug of our insert cable to output 1 of the H9, the left output. Connect the ring plug to output 2, the right output. Connect the TRS end to TriceraChorus's input. When the pedal functions in mono mode and you're connecting to another mono pedal, connect an instrument cable from out 1 to the input of the next pedal. If you wish to run TriceraChorus in stereo, simply add another instrument cable from out 2 to the right channel input of the next pedal. Even when TriceraChorus's input is set to mono, the pedal functions in stereo if both outs are connected. On the other hand, it is possible to accept the stereo signal, but output the signal from TriceraChorus in mono. This only works using out 1. The pedal will automatically mono-sum the signal when only out 1 is connected. Something to note, when in stereo mode, the tip of the TRS connector at the input corresponds to the left channel, and the ring corresponds to the right channel. They get routed to out 1 and out 2 respectively. When connecting high impedance signals like guitars or basses, make sure the level switch is set to guitar. For line level signals like keyboards, synths, or audio interfaces, set it to line level. Deciding whether to run the pedal in front of an amp or in an amp's effects loop is a matter of taste, but here are a few guidelines to help with our decision. In a mono rig, if we're running the amp fairly clean, it's easiest to connect it to the front of the amp using out 1. If we enjoy using an amp's driver distortion, I recommend experimenting with TriceraChorus in front and in the effects loop. Both positions in the signal chain render very different results. Generally, placing chorus before distortion, whether from a pedal or the amp's gain section, will preserve the integrity of the distortion, rendering a more focused sound. On the other hand, placing chorus after distortion tends to magnify the effect of the modulation on the distortion. The amount of gain present in the signal also plays a role in how the chorus sounds overall. Some musicians place the chorus after an overdrive, but before their distorted amps. Experimentation is key. As a matter of personal preference, I like TriceraChorus before my very heavy distortions, but when using slightly overdriven tones, I like to put it after. In part 1 of the TriceraChorus tutorial, I placed the pedal after my overdrive, mainly to highlight what the pedal is doing. To connect TriceraChorus to the effects loop of an amplifier, set the input switch to mono. Typically, the level switch should be set to line level for most amps. Start by connecting the guitar directly to the amp input. Next, route the amp's effects send to TriceraChorus's input. Then, connect the pedal's out 1 to the return of the effects loop. Now your drive signal will hit the amp's drive section first before it hits the TriceraChorus pedal. If we're running a stereo rig, the same guidelines apply. The easiest setup is running the amps clean. Set the pedal's input to mono and the level switch to guitar. Connect the guitar to the input of the pedal. Then, connect out 1 to the front of the leftmost amplifier and out 2 to the front of the rightmost amplifier using standard instrument cables. If we choose to run the pedal through the effects loop, there are 2 methods we can use. The first involves using one preamp section for both amps. Set the input switch to mono and the level switch to line. Connect the guitar to the front of one amp. Then, connect that amp's effects send to the input of our pedal in mono. From there, take out 1 to the effects return of the leftmost amp and out 2 to the effects return of the rightmost amp. This way, we have one set of controls with which to tailor the sound going into the pedal. Even though the pedal's input is set to mono, the pedal renders a stereo signal because both outputs are connected. Each output is directed to the power section of each amp independently. Another method of running a stereo amp rig using the effects loops allows us to use the preamp section of both amps, similar to the easy stereo setup from earlier. But now we are incorporating our pedal in the effects loop of the amps in stereo. First, set the input switch to stereo and the level switch to line. This configuration requires us to direct the guitar signal to the front of each amp using a splitter. I recommend using any splitter with an isolation transformer and a polarity switch on one output to combat any issues with noise or phase cancellation that may arise. We can keep it simple with something like a radial big shot set to both. Connect the outputs of the splitter to each amp. Another option I like is the Goodwood Audio Interfacer TX set to split sum mode. We can connect the guitar to the splitter's buffered input and route signal to dry effects neatly on a pedal board before the dual mono split. Then, route the effect send from each amp to the input of the pedal and connect the pedal's out1 to the effects return of the left amp and out2 to the effects return of the right amp. Because .9 pedals use a TRS connector for stereo inputs, long insert cables are not common, and connections may be difficult if the pedal is not near the amp rigs. As a solution, I recommend connecting the effects send and return of the amps to a junction box using standard cables. We can even mount it on our pedal board. Then, connect the tip end of the smaller insert cable to the junction that corresponds to the effects send of the leftmost amp, and the ring end of the cable to the junction that corresponds to the effects send of the rightmost amp. The TRS end goes into TriceraChorus. Lastly, connect out one of TriceraChorus to the junction pointing to the left amp's effects return, and out 2 to the junction connected to the right amp's effects return. Now we can send signal from our amps, process it through TriceraChorus, and return it back to the amps in stereo. Always keep in mind that using a rig with more than one amp makes us more susceptible to noise from ground loops, especially if we're in an environment not designed with audio in mind. In stereo setups, it's a good idea to have the capability to isolate one amp from the other by decoupling the input to one amp and the effects send and return of the same amp. Phase reversal switches are handy to make sure our signal is not accidentally getting cancelled out. Depending on our setup, decoupling and phase reversal are not always necessary, but now we're aware of how to combat these common problems. The USB Mini B connector serves a dual purpose. Connect the pedal to your computer with the appropriate cable, and take advantage of the Eventide Device Manager software to update the pedal's firmware and access preset management tools. Or use it for MIDI over USB with MIDI controllers that have USB host capabilities. For example, it is possible to use your iPad as a MIDI controller for .9 pedals. Connect the pedal with the appropriate USB adapter and Mini B USB cable. Using an app like MIDI Designer Pro 2, we can do things like program knobs to control the pedal's parameters, create buttons to send program changes, or generate sliders to control expression mappings. If we power up the pedal with the active foot switch and page button pressed, the blinking top two LEDs on the preset ladder indicate we have entered system settings. Here we can adjust 6 different features, like set the EXP input functionality, choose the bypass mode, engage MIDI Clock, assign a MIDI channel, put the pedal in kill dry mode, and activate a knob catch-up feature. Let's talk about the EXP input, which can be configured to one of 5 modes using the page button: Expression Pedal plus Auxiliary Switch, Triple Auxiliary, MIDI Box, and MIDI TRS. Expression Pedal is the default setting. The pedal automatically stores your new settings as you make them. Just power cycle the pedal to exit system mode and return to normal operation. When using either of the first 2 modes, Eventide recommends using an expression pedal with a 10 kΩ to 25 kΩ potentiometer. While higher ratings work, you may find that all the range is compressed at one end of the pedal travel. It's best to stick with the first recommendation. When in EXP mode, it's recommended to use a TRS cable for compatibility with a wider range of expression pedals. Always connect the cable to your expression pedal first, then to the EXP input. Afterwards, move the treadle back and forth so that the pedal can automatically calibrate properly. In the second mode, EXP+AUX, we can use an insert cable to connect an expression pedal and an auxiliary switch that is automatically mapped as a tap switch to control TriceraChorus' modulation rate. Keep in mind if MIDI Clock is enabled, this switch will have no effect on the rate. Having an auxiliary tap tempo switch will allow us to keep the pedal's right foot switch in preset select mode. When making your connections, the tip plug should be connected to the expression pedal and the ring plug to the switch. Please keep in mind that certain expression pedals that have TRS inputs will not work properly when connected with a single TS cable. For this mode, seek out TS expression pedals that have their pots wired as rheostats, where the wiper and reference voltage pins of the pot are wired to tip and the ground end to sleeve. We recommend the Mission Engineering SPH9 or any pedal that has a TS option. Otherwise, using a regular TS connector in a pedal that normally takes a TRS will inadvertently tie the end terminals of the internal pot together, exhibiting a 0 to 100 and back to 0 sweep range. TriceraChorus won't even respond in this case. If we want to use a TRS expression pedal in EXP+AUX mode, there is a way around this with a custom cable. Take a regular insert cable and replace the tip plug with a TRS plug. Wire them tip to tip and sleeve to sleeve, leaving ring disconnected. This cable configuration will allow us to use the same expression pedals that would normally work in EXP mode with this mode as well. For example, my trusty Dunlop DVP4 normally works fine in EXP mode with a TRS cable. If I switch to EXP+AUX mode and try to connect it with the tip plug of a regular insert cable, it won't work. But if I use my custom cable, it works without issue. Here's another tip. In the event we only want to use the EXP input as a tap switch for the modulation rate, set the pedal to EXP+AUX mode. Because tap rate functionality is normalized to the ring plug of an insert cable, we can use a TRS to dual TS cable and just connect the ring end to a switch. As we can see, having a dangling cable is not optimal. As an alternative, we can make a custom cable with a TRS plug on the TriceraChorus end and the TS plug on the switch end. Wire it tip to ring and sleeve to sleeve, leaving tip disconnected on the TRS side. Now we have one neat cable for a single tap switch. When the EXP input is set to triple aux, we can connect a 3-button foot switch using a TRS cable. The switch wired to tip is mapped to increment preset, while the switch wired to ring is mapped to decrement preset. The tip plus ring switch is mapped to load the preset. Please note, if we don't load our preset after searching, it will time out after a few seconds. When the EXP input is set to MIDI box, we can use an external MIDI 5-pin DIN to TRS converter to send MIDI via TRS. Some good examples are the MIDI box units from Disaster Area Designs and Morningstar Engineering. Make sure the TRS outputs are set to function as tip active. And finally, MIDI TRS mode uses normal MIDI opto isolation, allowing us to use an adapter cable to go directly from a standard DIN jack to TRS. Disaster Area Designs offers two 5-pin DIN to 1/4-inch MIDI cables, the 5P-TRS and the 5P-QQ, both good options. If you prefer to make your own cable, follow the Type A MIDI 2.0 standard, where the TRS connector's tip is wired to the DIN connector's pin 5, ring is wired to pin 4, and sleeve is wired to pin 2. We can also use MIDI TRS mode to receive signal from another MIDI over TRS capable pedal. Be aware that because Eventide .9 pedals only receive MIDI, it's better to place them at the end of a MIDI daisy chain, or connect them directly to their own TRS output of a MIDI controller or distribution box. Eventide pedals give us the ability to easily map parameters to an expression pedal. As long as the EXP mode is set to expression pedal or expression pedal plus aux switch, you can use this feature to turn any group of knobs all at once, allowing for smooth transitions of the effect for both subtle and dramatic changes. accomplish this, we simply need to set endpoints for heel and toe. Start by putting the expression pedal in the heel position. Adjust the knobs to your minimum or starting points. Then, move the pedal to the toe position and adjust the knobs to your end or max settings. Listen to the effect morph between min and max points as you rock the pedal back and forth. We can make an adjustment at any time, just be careful to put the pedal in the right position. A common mistake when we first start out mapping expression settings is only setting one endpoint without its counterpart. My favorite strategy is to work with one knob at a time, going back and forth from heel to toe, setting min and max points for every parameter that will influence my sound. That way, I ensure every start position has a corresponding endpoint. Something to keep in mind, we may set the minimum value to be greater than the maximum value. When we do so, as the pedal moves towards the toe, the parameter value will decrease. Finally, let's remember to save our settings. Otherwise, if we navigate to a different preset without first saving, we'll lose our hard work. To clear the expression pedal mappings for the knobs, hold the active foot switch, and while holding, press the active LED button until the preset ladder LEDs flash twice. The next adjustable feature in system settings is determining the bypass mode, which can be set by pressing the active LED button to choose between buffered, relay, and DSP+FX. This is also where we can adjust whether the pedal runs in kill dry mode. The first option, which is also the pedal's default mode, is buffered. Buffered is the best mode for when we're connecting our guitar to the input, but may be connecting the pedal's output to a non-instrument input. Non-instrument inputs are often low impedance, and will load the output of the guitar and change its tone. To combat this, buffered bypass allows the pedal to act as a buffer. Relay is optimal if we want to ensure a hardwired connection from input to output when bypassed. This is otherwise known as true bypass. It's important to pay attention to our level setting on the back of the pedal and make sure we're connecting devices with matching impedances. Otherwise, the pedal will not have unity gain and may result in a level change whenever you bypass. If this happens, try buffered, or the next option, DSP+FX. DSP+FX combines the audio at the DSP's inputs with the DSP's outputs, and stops sending any new input signal to the DSP-FX inputs. DSP+FX mode makes it possible to bypass the effect without abruptly killing the tail of the effect. Pressing the active LED button again starts the ladder over, but with the last LED on. This indicates the pedal is in kill dry mode. In this mode, no dry signal is sent to the outputs, only the wet effect. The mix knob simply adjusts the effect level. We can use this if we're running the pedal through a mixer send and return loop, or in the effects loops of guitar amps that are wired in parallel. If we're back in system settings, the active foot switch takes care of turning MIDI clock on or off. The preset ladder acts as our visual guide, so when MIDI clock is off, all LEDs on the ladder are off. When MIDI clock is on, all LEDs are on. With clock engaged, the modulation rate is controlled by the BPM it receives from an external device. Turning the rate knob in this case will allow us to access note values spread along the knob that will subdivide the incoming BPM. MIDI clock disables the auxiliary tap rate switch and controller change number 9, which corresponds to tap tempo. The pedal's default setting is MIDI clock set to off. The right LED button takes care of assigning the MIDI channel on which the pedal will respond. The preset ladder gives us a visual guide of the currently assigned MIDI channel. The default is Omni, delineated by all LEDs on. Continuously pressing the button will run through all 16 MIDI channels. We can use this handy table to see which lit LEDs correspond to the MIDI channel number we're trying to set. Lastly, we can adjust the catch-up mode by pressing the right foot switch. The default is catch-up mode off, indicated by all LEDs off on the preset ladder. With all LEDs on, catch-up mode is engaged. Why would we need catch-up mode? Picture this. We're performing with TriceraChorus on a setting that has the left modulation depth in the middle. Then, we decide to make a change to the delay for all voices, so we page over to the secondary set of controls to make our adjustment. When we go back to the primary set of controls, the left depth setting does not correspond to the actual current value of the left depth parameter because of the delay adjustment. Moving the left depth knob could lead to a monumental shift in audio as a result. To make up for this, the pedal has a catch-up mode, where the knob will have no effect on the signal until it catches up to the actual value of the parameter. When catch-up mode is on, the LED ladder will indicate which direction we need to turn the knob to reach the catch-up point. If the top LED blinks, we need to move the knob counterclockwise. If the bottom LED blinks, we need to move the knob clockwise. The closer we get to the catch-up point, the faster the LED will blink. Once we reach the point, all LEDs flash, and the knob is once again in control of the parameter and directly affects the audio. Keep in mind, if we change presets, it's likely the knob positions will not correspond to the actual parameter values, and they will need to be caught up to take effect. Because catch-up mode is a global control, we need to decide what mode best suits our needs. Once we've made our system settings, simply power cycle the pedal to store them, exit system mode, and return to normal operation. While all the system settings can be made directly on the pedal, they're also available on the Eventide Device Manager software. Just hook up your pedal via USB to a computer, open up EDM, and click OK once your pedal is highlighted in yellow. On the left side of the window, click on System Settings under Manage Device. There, we'll find all the available configurations. When using EDM, the system settings do not automatically get saved when making changes, so make sure you click on Update Device up top on the right to store them to the pedal. Periodically, Eventide releases updates to the pedal's firmware to improve functionality. Or sometimes it may be necessary to reinstall firmware that may have been corrupted somehow. To accomplish this, we need to use the Eventide Device Manager. Download the latest version off Eventide's website and connect your pedal via USB to a computer. The most surefire way to update firmware is putting the pedal in update mode. Simultaneously press and hold the right foot switch and right LED button while power cycling the pedal. Upon booting up, the first and fifth LEDs on the preset ladder will blink, indicating we are in update mode. Open up EDM, and when it recognizes the pedal, click OK. Navigate to the left side and click Check for Updates. This window shows us all the available firmware options. Next to the version number, we can read what changes have been made to each revision. Select the first option, which is always the most recent version, and then click Install Update. While the pedal is being updated, the first and fifth preset LEDs will continue to blink. In less than a minute, all the pedal's LEDs will flash, indicating the firmware has been installed and the pedal is now ready to use. Keep in mind that updating or reinstalling firmware does not mess with any of our custom presets or system settings. Also, it is possible to update firmware using EDM without putting the pedal in update mode. But using update mode eliminates any doubt in the process, mainly if we're troubleshooting the pedal. If for any reason we wish to restore factory settings, we need to be aware this process erases all user presets stored in memory and resets system settings to their default state. Thus, I recommend backing up our presets and system settings using the Eventide Device Manager. Connect the pedal via USB to a computer. Open up EDM and click OK once your pedal is detected. Navigate to the left side of the screen and click Backup to File. We have the option to name it and save the preset list to any location. This generates a .bak file that stores all presets in memory as well as the current system settings. Restoring factory settings allows us to work from a clean slate with both presets and system settings. Also, if you're troubleshooting the pedal, we recommend restoring factory settings after updating the pedal's firmware. Just remember to back up any custom presets beforehand. If we're working directly on the pedal, we can restore factory settings by simultaneously pressing the active foot switch and active LED button as we power cycle the pedal. Keep them pressed until we see the third preset ladder LED blink, indicating the pedal is conducting the reset. After a few seconds, the pedal will reboot and be ready to use. If we're working on the Eventide Device Manager, navigate to the top left side and click on Factory Reset under Manage Device. A pop-up will warn us this process cannot be undone, so this is our last chance to save our presets and settings. Click Cancel to exit the restore process. Otherwise, by clicking OK, it initiates the restore process. After about 8 seconds, the pedal returns to normal operation. At this point, we can continue using the pedal like normal and feel certain we're starting from a clean slate. Otherwise, we can restore custom presets and system settings from a previous backup using EDM. Navigate to the left side of the screen and click on Restore from File. Find the .bak file we created and click Open. After a few moments, EDM will restore the preset list and system settings.